this video, we're going to talk about wind power generation. I'm going to start this off with an anecdote which may be surprising to some, if not all of you, but the wind is actually a form of solar energy. When the sun shines, some of its light reaches the Earth's surface, heating it up. The heat on the Earth's surface warms the air above it, so different parts of the Earth will get different amounts of heat. So the air over the equator gets warmer than the air over the poles. The air over the desert is warmer than the air in the mountains. Should be pretty intuitive. The air over land gets warmer than the air over water. And as air warms, it expands. The warm air over land becomes less dense than the cooler air, and it rises into the atmosphere. What happens in turn is that cooler, denser air flows in to take its place. So it's this constant cycling of moving air that is what we call wind. And it's caused by the uneven heating of the Earth's surface. What wind turbines do is essentially they convert kinetic energy in wind into mechanical power and then into electrical power. The majority of wind turbines consist of 3 blades which are mounted to a tower made from tubular steel. There are less common varieties that have 2 blades, but we're not really going to focus on that in the class. So at 100 feet or more above the ground, the tower allows the turbine to take advantage of faster wind speeds, which are just found at higher altitudes. Turbines catch the wind energy with their propeller-like blades, just like those of an airplane wing. When the wind blows, a pocket of low-pressure air forms on one side of the blade. The low-pressure air pocket then pulls the blade towards it, causing the rotor to turn. This is called lift. The force of the lift is much stronger than the wind's force against the front side of the blade, which is what's called drag. And so it's this combination of lift and drag that causes the rotor to spin like a propeller. And then inside, there's a series of gears that increase the rotation of the motor from about 18 revolutions a minute to roughly 1800 revolutions per minute. A speed that allows the turbine's generator to actually produce alternating current electricity. It's different from solar PVs in this respect because photovoltaic systems are typically producing direct current, whereas wind produces alternating current. There's also a streamlined enclosure on a wind turbine called a nacelle, which houses kind of key turbine components. Inside the nacelle, you typically find gears, you'll find the rotor, you'll find the generator. Sitting atop the turbine tower, some nacelles are actually large enough for a helicopter to land on. So I'm trying to paint a picture here that these are very, very large pieces of machinery. Another key component of wind turbines are the controller. And the controller serves a purpose of essentially keeping the rotor speeds from exceeding usually about 55 miles an hour to avoid damage that happens from high winds. So the wind turbine is actually kind of constantly keeping itself within a manageable level, not overspinning, but spinning fast enough that it can generate alternating current. There are different types of wind turbines, and we're going to talk about these in the later courses where we focus specifically on wind, but there are those with the horizontal axis and those with the vertical axis, but I will talk more about the individual purposes of those in a later course. Solar power generation. So there's 2 typical systems for solar power generation. We have photovoltaic cells, which you see in the top right, and then we have concentrated solar power, which is at the bottom right. CSP systems are very interesting because it's essentially a collection of mirrors here, which are concentrating heat into the top of this turbine tower. It's cut off here, where it basically heats a steam turbine, turning a generator to produce electricity. I'm just going to open up these notes here so you can read them while I talk. So in a CSP system, like I mentioned, they concentrate solar radiation of the sun to heat a liquid substance, which is then used to drive a heat engine, that turbine, and drive this big, large electric generator. It generates alternating current, which can be easily distributed on the power network, just like those of large wind turbines. Photovoltaic cells, also known as PV, these are solar panels. They differ from kind of solar thermal systems and that they actually don't use the sun's heat at all. They are not using heat to generate power. Instead, they use sunlight through the photovoltaic effect to generate direct electrical current. So they generate DC. The DC will eventually be converted to alternating current with the use of inverters and transformers in order to have it kind of distributed on the power network. So let's talk a little bit about CSP, concentrated solar power, versus photovoltaics and their energy storage and efficiency. CSP systems are capable of storing energy by the use of thermal energy storage technologies and using it at times of low or no sunlight, like on a cloudy day or overnight, to generate electric power. This capability increases the penetration of solar thermal technologies like CSP in the power generation industry because it helps overcome intermittency problems. It helps overcome issues about not getting electricity when the sun isn't shining. Photovoltaic systems, on the other hand, do not produce or store thermal energy. They directly generate electricity in real time. And as I mentioned before, electricity can't really be stored. So it's much easier if it's converted to a primary energy source, which is what concentrated solar power does. It converts it just to heat. So for this reason, CSP systems are far more attractive for large-scale power generation because they are more efficient than a lot of other energy storage solar energy production facilities. PV systems, I would say, constitute a bit more of a proven technology, however, because they can be built easier, at lower cost, and at a much shorter time than CSP plants. And CSP plants also require a lot of land. Moreover, PV panels also have a demonstrated and substantial price drop, and that kind of economic efficiency that's been found over the last 10 years with photovoltaic cells hasn't been matched with CSP plants. I think between 2009 and 2017, photovoltaic cells, their levelized cost of electricity has dropped about 76%. That efficiency gain has not been found with CSP. So let's just look at the side here where I listed some characteristics of both. In PV systems, they use sunlight through the photovoltaic effect to generate electricity. They're not using heat. They produce direct current. Not easily capable of storing electricity, but they are cost effective. CSP, on the other hand, concentrates radiation of the sun to heat a liquid substance which drives a turbine, just like in all thermal generation forms like geothermal as well as fossil fuels. It produces alternating current, which is easier to distribute on the grid, but it is cost prohibitive. It's a more costly device.